Welcome to the classroom. Today we're talking about weathering and erosion. What's weathering and erosion? Well, weathering is the breaking down of rock with time, breaking off fragments of the rock. And erosion is actually removing those pieces and transporting them away. Why is that important? Well, that's how we get these small fragments of rock that become our sedimentary rocks. Those sediments get deposited on our riverbanks and create nutrients for our soil to grow crops and various things like that. Lots of interaction. We need weathering, erosion, but it breaks down rocks with time. And actually, it starts with fractures in the rock. And those fractures, they hold clues of what's happened. What can we understand about what's happened to a rock from fractures? Well, actually, the cracks you see here on the surface, they would exist in this rock. Or a fracture is an opening and a void space. And when water flows in there or you get dust flowing in there from the wind, it can fill up that crack. And that's one thing that can be recorded. The position and orientation of that crack, it can record the tectonic history that has broken this rock. And if we compress that rock or we bend it, we can create fractures. That's opposed to metamorphic rocks where we can bend them because of the heat and pressure, okay? And those fractures on those surfaces, when water's flowing through them, we can grow crystals, okay? You may see some crystals on this surface. These are two fractures in the rock that intersect and create this block that has broken off. Now, this block may have broken off when they transported it here, but the fracture traces go back, and if we look at the surface, we can see little crystals of probably calcite glinting in the sunlight. When water flows, we can also see some staining. And if we come around and have a look at the backside, we have a great example of that. Look here. We've got a sedimentary bed along here, and there's even some little void spaces. And this rust color is staining due to water flowing through this bedding plane and out. And it's taking some minerals that are inside that fracture plane and washing them out over the surface and creating this rusty stained color. And that's really indicative of water flowing through the crack. And when water is flowing through cracks in the wintertime or even in the spring, we can get freeze-thaw cycles. And you know that ice expands when it froze in the crack. It's going to jack that crack open, or it's going to take that crack over here and break off the piece of rock. And that ice freezing and thawing is going to create pressure that grows cracks along this rock surface. So water is a key component of weathering because it can transport minerals that grow in the fracture. It can form into ice, okay? And it can also be a force that removes the rock fragments off of the block in a big rainstorm. You get water pressure built up in a big crack, and it can actually be enough pressure to break that piece of rock off. So those are all important factors that we can actually identify in the field, what's been happening with those cracks, both historically and presently. And it's the present that is important. Why is it important? Well, actually, from an engineering perspective, understanding the orientation of our fractures and whether or not they're going to form a block that can fall off, say at the roadside or in an underground mine or an open pit, it's really important to understand where blocks of rock are going to fall off because we can reinforce them in our engineering structures. And so we can do a lot of studying of those fractures in the field and collect information that helps us design that support to save people's lives and make places safe for us to go interact. Thanks for watching.